Hello and welcome to this first VMK in the mathematics series. In this VMK I'll explain to you lines in two dimensions, so specifically the equations behind lines in 2D as well as how to sort of identify what each of the parameters in the equations mean. If you find my tutorials helpful, please go to my website at www.mathicknows.com and support it. You can do this by clicking on the PayPal icon and donating some money, or clicking on the Google ads found on the right side of the screen. So let's begin. The general equation for a two-dimensional line is shown here. Y equals mx plus b. Now, y represents the y value along the line, x represents the x value along the line, m is the slope of the line, and b is the y-intercept. It's probably best to show an example here of what each of those values mean. So on the screen here we have a standard Cartesian space where we have x along the horizontal direction and y in the vertical direction. The origin 0, 0 is in the middle. Now, I have a line here drawn in blue, and you can see it's passing through the center, 0, 0, and it's going upward. For every unit along the x direction that it moves one direction upward in the y. So here you see this is point 1, 1, this is 2, 2, this is 3, 3, and so on. So the b value in our equation, y equals mx plus b, is the y-intercept. The y-intercept means where does the line cross this y-axis here. So when the b value is equal to 0, then that means that the line passes through 0, just like shown here. Now the slope of the line represents this steep, so how much is this inclined? Well, the way that this line is drawn, m is equal to 1, which means for every unit 1 in the horizontal direction you move, you'll also move vertically 1 unit. So this is slope 1, b equals 0. How to define a two-dimensional line? Well, there's a number of ways of doing it, but the two most convenient ways are listed here. You can define it either by using one point and the slope. So you can have a point, I just labeled it P1, and the x-coordinate and the y-coordinate value, you need to know both of those, and the slope. So for instance, if I were just to draw here really roughly, you could have a point, so this is x and y, and the slope would give us sort of this angle here that we move. So the way that I drawn it here, x is slightly larger than y, so this slope would be less than 1. And with those two pieces of information, the point and the slope, you can then define a line. Another way to do it is to have 2 points. So you could have P1 and P2. So in the previous example here, this would be P1. Another way to define a line would be with 2 points. Now I'm using a mouse to draw these, so my lines aren't very straight, but I hope you get the general idea. So this would be P1, and this would be P2. And with those two pieces of information, again, P1 you'd need to know the x and y value, and for P2 you'd need to know the x and y value as well. If you know all that information, you can then generate the equation for this line. And the other way is if 1 point and the slope. Now the slope of a line is given by this equation here. It's equal to the change in y divided by the change in x. So again, if we had 2 points like this, then the slope of this line would be, this value would be y2, and this value, which would be y1. You subtract these two, so you get this distance here. And for the x, you take the x2 value, which would be this value here, and then you subtract from it x1, which would be this value here, and you get this distance here. Given those two values for the change in the y direction and the change in the x direction, you can then define the slope by dividing the two. Slope of a line determines how steep the line is. So for instance, if m is equal to 0, that means we're drawing a horizontal line. So it would look like this. Now, we can see this because to have m equal to 0, the top part of this equation would have to equal to 0. Well, if the top part is equal to 0, then that means there is no change in the y direction. So that means that the line has to only go horizontally. If m equals 1, then the line is angled at 45 degrees, which was that first example that I showed you. It will look something like this. And then if the line has a slope of infinity, then that means it's a vertical line. So the line itself would look something like this. Now I'll show a few examples of all these different kinds of lines. In our first example here, I was showing a line with a slope of 1. If we change the slope to 0.5, then we can see that the line is now not as steep. So here, with 0.5, that means that you travel in the x direction 2 times as much as you travel in the y direction. So for every 2 units horizontally, you'll move 1 unit up. 2 across, 1 up. This gives you a slope of a half. And again, slope is equal to rise over run. So if you take the rise, which is shown here, by 1 unit, and divide it by the run, which is the horizontal value, which is 2 units, you get 1 divided by 2, which is a half. So again, slope here is equal to a half. If we change the slope to be 3, we get the following. Now we can see that the line is more steep. So for every 1 unit across that we move, we actually move 3 units up. Now, what would we do if we want to actually offset this line vertically? Let's say instead of wanting it to cross at the 0, 0 point, we wanted it to cross here at the 0, 2 point. Well, that is controlled by that b value. If we set b equal to 2 for this example, we'll get the following line. And we see now the line crosses at y equals to 2 and x equals 0. And the slope remains this. I can change it back to be slope of 1, and you can see what we'll get. So this is what we get if we have slope of 1 and a b-intercept equal to 2. So you see, in 2 dimensions, there's only 2 parameters that we really use to determine which way the line is pointed. We use m to determine how steep it is, and b to determine where it is along this axis. If you can remember this equation, y equals mx plus b, then you'll be able to define any 2-dimensional line.